This is Paul, the SDR guy. This is episode 26. This is part 3 of our ongoing SatDump version 2.x video series. And today we're going to be learning about lookup tables. Well, what's the function of a lookup table? The general idea about LUTs in satellite remote sensing, especially for weather forecasting, is to make certain things more obvious. Well, what in the heck is a lookup table? From general computing, it's a table where there are keys and values. Here is an example of a key of 1011, and this is mapped to a value of 72. In the case of LUTs, we're going to be looking at grayscale LUTs and color LUTs in this video. And basically, there's a horizontal line underneath the graphics, and I did put a blue rectangle around these LUTs so you could see how far it extended, because once it goes to white, you can't see it. So in this particular case, the top example, if the value that's input is 50, that will map to this particular shade of gray. Down on the bottom, these are just mapping a specific value to a color. For example, the classic red, orange, yellow, green, blue, indigo, violet, or rainbow. Here we have an input value of 25, and this maps to an output color of orange. We're going to now look at a basic example of what's called a stretch LUT. As you can see, the LUT is black for a while and then gradually moves to white. This is represented by a curve. The effect that the contrast is stretched between 2 points, so that the very white and very bright regions are compressed while the midtones are stretched. This gives a better contrast range for the midtones, where usually most of the information is contained. We're going to now give you a brief explanation of MERCI 3, which we're going to mention in the following slide. Well, what is MERCI 3? It is a multispectral imaging sensor designed to observe Earth and many wavelengths of light, from visible to infrared, and it flies on satellites like FY3D, which is part of China's Fengyan 3 series. And this collects data on that's used for weather monitoring, vegetation and agriculture tracking, ocean color and temperature, snow and ice coverage, wildfire detection, air quality, and aerosols. And here is a LUT for that. And notice how the black to gray transition, you can see it here, happens very quickly, but the gray to white is much slower and longer. Well, we can also have stretch LUTs with multiple breakpoints. You can have multiple breakpoints or points where the transitions are not smooth. These can be used to enhance particular kinds of boundaries, especially in temperatures. For example, the cold climate LUT that's shown next. The rightmost part from black to gray is a normal stretch LUT. Then you have a breakpoint that signifies the point at which the cloud tops of thunderstorms start to have ice crystals instead of water droplets. And then it continues leftwards from other breakpoints corresponding to other important temperatures. Another subset of LUTs are color maps. These are just mapping a specific value to a specific color. We can combine a stretch LUT with a color map. You can naturally combine a stretch LUT with a color map. This is the case of the cloud top infrared enhancement. In this case, the distinction between the interesting temperatures and the not interesting ones is stark, as the interesting ones are colored while the others are just a normal grayscale. We also have diverging color map LUTs. Diverging color maps. So here's a blue to red. Blue means you're from moving from the center outwards, getting colder. And then on the flip side, as we move outward, it's getting hotter. An NDVI lookup table maps grayscale values from a calculated normalized difference vegetation index, typically ranging from -1 to +1, to specific colors that visualize vegetation health. The NDVI LUT is both a diverging LUT as well as a stretch LUT, NDVI being a value that is unitless in a range from -1 to +1. SatDump uses only the 2D kind, although the 3D kind is similar enough in concept. Sorry about that. And we want to make sure that we remember how in the previous explanation I said that a LUT essentially works like a translator. You put one value in and you get another value out, or three if it's a color LUT corresponding to the red, green, and blue channels. So here we have an example of a 2D LUT. For 2D LUTs, it's the same but twice. Put in a value for the x-axis, put in a value for the y-axis, you get a value out. The value being whatever is the point that intersects with the two lines, the x line and the y line. And in this example, we're showing three different values for R, G, and B. These are mostly used to provide false color imagery for satellites with only a single visible and infrared band. First of all, the visible albedo or reflective radiance is plotted on the y-axis. This serves to distinguish clouds and snow, as those have a very reflective, and that's a high albedo surface. As you might have noticed, if you slice the 2D LUT in the vertical direction, it's nothing more than a bunch of 1D LUTs stacked together. Let's do an experiment to prove that. I have sliced the last pixel of the 2D LUT above. It resulted in this. And here we're zooming in on it for some additional clarity. And now let's apply it to a satellite image. So this is before we apply the LUT. And this is after applying the LUT. What we have achieved is simply yet another stretch LUT. As I explained in a previous slide, we have stretched the contrast a bit, and there is a brown tint to the image. Now let's slice the 2D LUT horizontally instead of vertically. This time we will apply it to an infrared image instead of a visible one. I have taken it from the middle, the slice that is, otherwise it would not be clear as the top is all black and the bottom is all white. Now let's apply it to a satellite image. Again, what we have achieved is having a color on a monochrome image as with the 1D rainbow LUTs. Now let's combine the two together. And this is a result. Well, how does that work? The temperature is the x-axis, and it decides the color of the land, with warmer colors having a more desertic view. The visible channel, that's albedo, the y-axis, decides how bright the scene is. We can also generate our own custom LUTs using the built-in LUT generator. And there's documentation for SatDump 2.x. I'll be sure to include the documentation in the video description. I want to thank Lego 11 for heavily contributing to this video. I have learned a great deal about satellite LUTs during the creation of this video. I hope this video helps you understand how LUTs work and the tremendous value they can provide to satellite imagery. Thank you for watching. Please consider liking my video and subscribing to my channel. Have a great day.